Yeah.
All right, here it is. So we have a series from n equals 1 to infinity of -1 to the n plus 1 over root n, and it converges to some value of s based on the alternating series error bound. We want to know the least number of terms that must be summed together to guarantee a partial sum that is within 0.03 of s. And they've given us 4 different options here. So if we want the error to be less than 0.03, that means that the next term has got to be the least number of terms. So we just need the next term to be a value that is less than 0.03. And if it is, then we know that our error must be clearly less than 0.03. So if we, for example, take the, if we have 34 terms, the next term would be 35. So that would give us the square root of 35 up there. And if you do 1 over the square root of 35, that's, I don't know. Let me grab it. I got my phone here next to me, so I can just approximate that square root real quick. I vaguely know what it is, but there we go. So this one, the 35th term, gives you 0.169. This one, the 334th term, if you do that one, you end up with 0.0547, which is still more than 0.03. If you do this one, the 1112th term, when you square root that and do 1 over that, you end up with 0.029988. And so since this is less than 0.03, we're guaranteed that our error is also less than 0.03 using the 1112th term. Does that make sense? Just plugging in that n value, or the next n value, into the series to find that term.
Right. Yeah. Yeah.
Cool. Other questions? All right, next one we're going to do here is 24. Hopefully. Find it in here. There we go. All right, number 24. So we have a function with a derivative that is sine of x squared and f of 0 equals 0. We want to know what are the first 3 non-zero terms for the Maclaurin series for f. And so let's see here. So all we got to do then is, we know that f of 0 is 0. So our first term is 0. That's not a non-zero term, so I'll have to worry about the rest of those in a minute. Then f prime of 0 should be, we plug in 0 to this, should end up getting 0. So 0 x to the first over 1 factorial. What's the derivative of sine of x squared to find f double prime? That should be 2x times the cosine of x squared, which is also going to be at 0 equal to 0. And then our next one should be f triple prime, which should be, if we use the product rule on that, 2x times negative sine of x squared times 2x. That one's going to be 0 plus, and we got 2 cosine of x squared. So that one's going to end up being, I should probably leave that there. That one's going to end up giving us what? Just equals 2. So we're going to end up with 2x cubed over 3 factorial. So our first non-zero term is just going to be x cubed over 3. That gets rid of choices A and B for us. And then the next one, it's an unpleasant derivative here. This is negative 4x squared sine of x squared plus 2 cosine of x squared. And so our fourth derivative, which should give us whichever one of C or D it might end up being, should be negative 4x squared times the derivative of sine of x squared, which is going to be cosine of x squared times 2x. That whole part of it's going to be 0 again. And then we've got plus, or actually it's going to be a minus 2 sine of x squared times the derivative of the x squared. That's going to be a lot. That's going to be a lot of terms in there for us to come back to one that's not 0. That's going to be annoying to get up there to the 7th. Let's see here. How can we go about this in a better way? Well, these ones are just going to keep being zeros. Maybe negative 8x cubed cosine of x squared minus 4x sine of x squared. All right, so, well, we take another derivative. Man, that's a lot of derivatives to get up to the 7th. But the next one is going to be negative 8x cubed times the 2x. So that's negative 16x to the 4th. It's going to become a positive sine of x squared, which is, again, 0. And then this piece is going to be minus 4 sine of x squared, which is going to be 0. And then this other part is going to be minus 4 or minus 8x squared cosine x squared, which is going to be 0. And then you'd have to take another derivative and then another derivative. Man, okay. Our next derivative, what was that? Oh, that's a 16x to the 4th. Let's see, looks like this one's going to continue to be 0. This one's going to continue to be 0. But this one, if we take its derivative twice more, is going to give us a negative 4 times 2x times cosine x squared. And when we take the derivative of that, that's a piece of the 6th derivative. And so then a piece of the 7th derivative should be negative 8x times the 2x times the sine of x squared. And then we should end up with a minus 8 cosine x squared is this other piece of this one. So we end up with a minus 8 times 0. So the coefficient should be minus 8x to the 7th over 7 factorial, it looks like. Nah, there had to be other terms in there. There's got to be a better way to go about that than taking that many derivatives. I guess what we should probably do is that's not going to work either. I don't offhand see another way to do that without taking all those derivatives.
May I don't know if this is dumb or if I'm missing something, but could you, oh wait, f prime of x is, oh, I thought you could maybe do the Maclaurin series for sine and then plug in x squared, but I guess you can't do that.
Yeah, that's what I was saying. I guess this is a non-calculator. There's got to be a better way than taking 7 different derivatives there. The sine of x squared doesn't integrate using an elementary antiderivative. Let's see here. If f prime is sine of x squared, I suppose. No, I guess nah. Yeah. Easier way to do this would just be to write out the series for sine of x squared and then integrate it term by term. So the series, I think that's what I would. That's definitely what I would do. Now that I think about it for a second longer here, so I would write out our series. So f prime of x, which is sine of x squared, ought to be, let's see, our first term for sine ought to just be it's not going to work out, is it? That should that work out? Okay, sorry. Okay. So if I have sine of x is x minus minus x cubed over 3 plus x to the, or not x cubed over 3, but x cubed over 3 factorial, x to the 5th over 5 factorial. And I make that x squared, then that should become x squared minus x to the 6th over 3 factorial plus x to the 10th over 5 factorial and so on. Okay, yeah, and so then just integrate these term by term. So x cubed over 3 minus x to the 7th over 7 times 3 factorial. That's much easier. X to the 11th over 11 times 5 factorial. That'll work out a lot easier. That's much better than doing it the other way. Write out your series for sine, make it sine of x squared, and then integrate term by term. And this definitely satisfies f of 0 is equal to 0. And so looks like, I don't know, what did that come out to be then? 7 times 3 factorial is 42, so it must have been D. This was all bad waste of time. Find an easier way to do it. Yeah, I mean, yeah, just guessing between C and D. Yeah, I mean, D seems to make more sense because of the factorial. So if you were just trying to take an educated guess between C and D, D would make more sense. But this is I'm sure how they expected you to go through and do this one. Does that make sense? Rachel, does that make sense? Sorry, that took a minute there for me to come up with a good way to do that one. Okay. All right, number 30 is the next one we're going to look at. Oh, wait, we just did 30, right? 30 is the one I did for, no, I did 90 for Sean. 30. Okay. All right, so for number 30, we've got this power series converges at x equals 7. It diverges at x equals 9. We want to know which of these following things must be true. So first off, we know that since this is x minus 4 to the n, that we know that at the least it could converge on is the open interval 1 to closed interval 7. That's the least that it could possibly converge on. It might converge on more than that. We know that it diverges at 9. So the only thing that is guaranteed here is that this converges at 2, because 1 does not necessarily fall in that interval, and -1 definitely it does not. Well, it could theoretically converge at x equals -1. We could have something like 1 to 7. That'd be fine. But this is not guaranteed. The only thing that's guaranteed is 3 units to the right. It includes that 7, and 3 units to the left is the interior of the interval of convergence, and it has to be open there. Could be closed, but it's guaranteed to at least be 1 to 7 open on the 1. And since it diverges at 9, we could go as far as to saying that this could be true. Right? It could converge for -1, but diverge at 9, and that could be our interval. But that's not guaranteed either. This is the only interval in which it's guaranteed to be true. Does that make sense? So that's like that's B. Hopefully that makes sense. And then also 85. You're late, Noah. Yeah. Next person. Ah. You didn't make it up as early. All right, we've got f is a function here such that f of -x equals -f of x. And then we've got that the integral from 0 to 2 of f is 5. We want to know the integral from -2 to 2 of f of x plus 6. So first off, what does f of -x equals -f of x tell us about this function? This tells us that this is an odd function. I remember that from like years ago. What is an odd function? An odd function is one that is symmetric with respect to the origin. So that means that pieces in the first and the third quadrant here ought to cancel each other out. So if we're looking at the integral from 0 to 2 of f of x is 5, then what should that tell us about the integral from -2 to 0 of f of x? Should be a -5, right? This piece should cancel out with this piece. And so if we were to think about this as -2 to 2, well, this is the integral from -2 to 2 of f of x plus the integral from -2 to 2 of 6. And the integral from -2 to 2 for an odd function that's symmetric across the origin should become 0. So then we've just got 0 plus 6x from -2 to 2, which is 12 minus -12, which is 24. That makes sense or no? Cool. Any other questions that anybody has? No more questions? From all those 45 multiple choice, people only had questions on 4 of them. All right. In that case, I have to record. So now that I'm recording again, 4 is our f of 0, 5 is our f prime of 0, -1 is our f double prime of 0, and then it's x to the first over 1, x to the second over 2 factorial. And then we just evaluated it. Everybody good with A?
Good.
All right, G is f of x cubed. And we want the 5th degree Taylor polynomial for G prime. So first let's write out what G is. So G, all we need to do is just replace the x's in f of x with x cubes. So G is 4 plus 5x cubed minus x to the 6th over 2. And so our 5th degree polynomial here should be, for G prime, derivative of 4 is 0, derivative of 5x cubed is 15x squared, minus 6x to the 5th over 2, so minus 3x to the 5th. Easy enough? Didn't give you guys the points. The first one, they gave you 3 points for this. And they gave you 2 points for the polynomial and 1 point for the approximation. And here they gave you 1 point for substituting in x cubed and then 1 point for taking the derivative. Good?
Yeah.
All right. 3rd degree Taylor polynomial for f about x equals 1. So this one should just be f of 1. And then it should be 3 times x minus 1. And then what's it, 3rd degree, right? So then we should have minus our x minus 2, x minus 1 squared over 2 factorial. And then we should have a minus, a plus 3 halves of x minus 1 to the 3rd over 3 factorial. Which we could simplify. 8 plus 3 times x minus 1 minus x minus 1 squared plus, and then this is we simplify that down, that looks like that's just x minus 1 cubed over 4. And they gave you 2 points for that. 1 for the first, well, 1 for any 2 terms and 1 for the other 2 terms that you did not get the points for. Everybody good there with C.
I know you only have to explain on a digital test, so you probably won't be writing this stuff out, but you have to simplify completely.
No, you don't need to simplify it completely, actually. I mean, it's nice to, but not required.
All right.
All right, and for part D, we're going to use a Lagrange error bound, and they're telling us that the fourth derivative of f is less than or equal to 300 for all values between 0 and 1.125. We're going to use the third degree Taylor polynomial for f around x equals 1 to approximate f of 1.1 and use the Lagrange error bound to find upper bound on the error of that approximation. So our error for part D, different color, I can't see that very well. Our error ought to be less than or equal to the absolute value of the fourth derivative of our function times our the x value that we were looking at, which was what, 1.1, I think, minus our 1 to the fourth over our 4 factorial. So our error is less than or equal to this, and our fourth degree, our fourth derivative is always going to be less than or equal to 300. So this is 300 times 0.1 to the fourth over 4 factorial, which is 24. And so we should be able to simplify that down. This is 0.1 to the fourth. So that should turn that into a 2400 in the denominator, and that'll cancel out with the 300 there. So we got 3 over 2400, which ought to be 1 over 800. So our bound on our error is 1/800. Good or no?
Good.
Sure. All right. Anybody have any other questions about anything before the AP test tomorrow, for those of you that are taking it tomorrow?
AP Calc BC curve, same or different from previous years?
I mean, you mean in terms of same or different to the AB? I mean, it changes from year to year, but it's fairly similar to what the AB curve normally looks like. Where if you're around a 70-ish out of 108, maybe a little higher, 72, 73, that's pretty much, you're pretty set on a 5. And then about 8 to 10 points below that is a 4, the lowest 4, and about 12 to 15 usually below that is the lowest 3. Yeah. Yeah, I can't promise, but you know, from year to year it changes. Some they don't release them every year to me, so I don't know for sure, but that's a decent ballpark on what it should be. And
Right.
your, you know, the scoring is, you know, out of 108, so theoretically it should be, you know, exactly the same as what it was on the paper test, is what they've said. So 54 from the multiple choice, 1.2 times the number you got right, which could be up to 45 of them right, so it could be 54 points, and then the 6 9.3 responses. So should be pretty straightforward, I hope. Other questions?